All right, 3-6. We are almost done with chapter 3. This last section, we're going to be talking about lines in the coordinate plane. So we're going to review a little bit more algebra stuff that you did with graphing lines. So some of this should be review. So the graphing lines and writing equations in slope-intercept and point-slope form. I'm actually not going to emphasize point-slope form, but if you want to use it, that's a-okay with me. I'm not going to talk about it in this video, but we can talk about it in class. But also you should be able to classify lines as parallel, intersecting, or coinciding just by looking at the formula. So without graphing it. Okay, so there's four parts to this video. First, we're going to talk about slope. Then we're going to talk about slope-intercept form. Again, we can talk about point-slope form in class, but I'm just going to emphasize slope-intercept. Then we're going to talk about special lines. And then lastly, we're going to be classifying the lines either as parallel, perpendicular, intersecting, or coinciding. Okay, so slope. This is stuff we did in Algebra 1 last year. Slope, remember, is rise over run. Or you can think about it as y2 minus y1 over x2 minus x1. So they have to give you 2 points, right? And you subtract the y's, and then you subtract the x's, and that gives you your rise over your run. Okay, so I want you to first find the slope of mn, and I want you to find the slope of st. And if you need to graph it, that's fine. So m is at 0, negative 2. So here's m. N is at 4, negative 4. There's n. And then, so there's one line segment. And then S is at 4, 1. And T is at 1, negative 5. 3, 4, 5. Okay. And the question's asking you, are these lines, now that we've graphed them, do they look parallel, perpendicular, or intersecting? Well, they don't look parallel, so we can cross that out. But let's see if they're perpendicular or intersecting. It's kind of hard to tell, so we need to do some algebra. Let's look at the slope. So M stands for slope. The slope of MN, or if you wanted to count, I want to make sure you guys can do both, the algebraic way and the counting way. So I wanted to do MN. Let's see, I need to subtract the y's. So negative 2 minus negative 4, and then I need to subtract the x's, so 0 minus 4. So that's going to be 2 over negative 4, so this slope should be negative 1/2. And if you wanted to check, negative means we're going to go down, so we go down 1 over 2, down 1 over 2. So that's how you can find it in your picture too, is by counting. So that's correct. Now if I wanted to do the slope of st, again, the algebraic way to do it is subtract the y's, so 1 minus negative 5, and then subtract the x's, 4 minus 1. And notice how I'm going in the same order each time. I took from this ordered pair first for the y's, so I'm going to pick from this ordered pair for the x's. So the two negatives make a positive, so that's going to be 6 over 3, which I can reduce down to 2 over 1. So that means I'm going to go up 2 and to the right 1. So let's see, up 2 over 1, up 2 over 1, up 2 over 1. Sweet. All right, so these are my two slopes. Now, if you look at the slope, we have negative 1/2 for one and 2 over 1 for the other. These are called opposite reciprocals. Since they are opposite reciprocals, that means that these lines are perpendicular. So I can say not just that they're intersecting, but more specifically that they're perpendicular. Parallel lines, remember, maybe you remember from algebra, parallel lines have the same slope. We're going to talk about that more at the end of the video. Okay, so we've talked about slope. The next thing we need to talk about is slope-intercept form. When I say slope-intercept form, that's y equals mx plus b. Remember, m is your slope and b is your y-intercept. So that's where it hits this y-axis. Okay? So if I wanted you guys to graph, for example, y equals 1/2 x minus 4, this is your y-intercept, the one without the x, so you would start at negative 4, and then this is your slope, so you'd go up 1 and over 2. So up 1 over 2, up 1 over 2, and there's your line. Sweet. Now what I want you to be able to do besides just graphing is I want you to actually come up with the equation. So number 2 is a little bit more challenging. I'm going to scroll down. Number 2 says find the line of a slope with a slope of 6 that goes through the points negative 3, 3, negative 4. If you wanted to graph it, let's see, 3, negative 4 would be here, and then slope, that's 6 over 1. So I'd go up 6, 4, 5, 6, and over 1. So there's my line. And I know that it's going to intersect way down here, so my y-intercept should be really, really negative. To do this algebraically, what you're going to do is we have y equals mx plus b. We know the slope already. That's 6. Okay, so now I have y equals 6x plus b. Well, this x and the y I've already given you here. This 3 is your x and this y is your negative 4. So you're actually going to plug in x and y. So now my equation would be negative 4 equals 6, that's my slope, times x, that's 3. But I don't know what b is. So the next thing you're going to do is solve for b. So 6 times 3 is 18. And then I'd have to subtract 18 from both sides, so I'd have b equals negative 22, which looks right? I said the slope, the y-intercept, is going to be way down here. Negative 22 is really far, so that's perfect. The last thing you need to do, though, is you need to take your slope, you need to take your y-intercept, and you need to plug it back into the slope-intercept form. Point-slope form doesn't matter to me. So y equals slope x plus y-intercept, which is negative 22. That would be your final answer. Okay, again, this should be review from algebra, but I realize it's been a long time. I want you to try to do number 3 in your notes. Try to be number 3. We're going to check this in class. And if you're stuck, that's okay. Look in your notes, maybe in 6-6, or sorry, 3-6 in the book. Maybe that'll help you out. I'll give you a hint. You might need to figure out what the slope is first, and then use the slope to do exactly what we did in here. Then solve for b. Okay, so first find slope, then go ahead and use the slope and 1x and 1y to solve for b. Again, this should be review, so if you're not sure what to do, that's okay. We'll talk about it in class. All right, we're gonna something else we need to remember from algebra are special lines. So when I say special lines, I mean we're gonna have vertical lines sometimes, and sometimes we're gonna have horizontal lines. And this always really confuses me, to be completely honest with you. When I know I can remember that one of them has to be a y equals a number, and one of them has to be x equals a number. And I honestly always forget which one's which. So what I have to do, guys, don't make fun of me, is I have to pretend to graph it. So if I had to graph this vertical line, where would it hit the coordinate or the axes? And it's going to hit it right here. So this is the x-axis, right? So I could say, okay, that's x equals 3. Now anywhere on this line, it doesn't matter if my point's right here, x is still going to be 3. And up here, even though the y has changed, the x is still always 3. So that's my equation. So vertical lines are always going to be x equals a number. There's never a y in it. Horizontal lines are going to be exactly the opposite. If you think about it on a coordinate plane, this point hits it at a y, like y equals 4. Okay, if you look at this point on the line, it's still y equals 4. Even though the x has changed, y still equals 4. So whenever you see an equation like y equals a number, that means you're going to have a horizontal line. No slanted lines, like no diagonal lines. Okay, so for number 4, and I have it written down for you here as well. Number 4 says write an equation for the line with x-intercept of 3. X-intercept at 3. I don't think this isn't gonna be a special line. I don't know why I put this in here. Sorry. Let's say, okay, let's do this one anyways, even though this is my bad. Okay, x-intercept is at 3. This is the x-axis, so that means it's going to touch that axis at 3. And then the y-intercept is at negative 5. So it means it's going to hit this axis at negative 5. This is actually a pretty easy question, even though it looks weird. Here's our line, and since you have it graphed, can you change this so that it's y equals mx plus b? Okay, so this one's 4a. We'll call this 4a. Give me that equation. 4b, go ahead and write the equation of this supposedly horizontal line. So give me two equations. Equation of a horizontal line that I drew, and then give me the equation of this one with the x-intercept at 3 and y-intercept at negative 5. All right, and last but certainly not least, parallel lines versus perpendicular lines versus intersecting lines versus coinciding lines. Oh my goodness. Okay, so we already know parallel means that they never meet, and we should remember from algebra that that's because they have the same slope. So if you look at these two equations, they have the same slope. But notice that their b's are different, so their y-intercepts are different. Those are going to be parallel. Coinciding lines, if you notice, they have the same slope, but notice they also have the same y-intercept. Coinciding lines means they lay right on top of each other. So you can think of it as being the exact same line. Intersecting lines are lines that have different slopes entirely. And intersecting means like they could look something like this. All right, they just meet once. Then I also want you guys, since you're honors and you're so fantastic, I want you guys to realize what perpendicular lines look like. Again, we don't have to graph it. We can just look at the equation. We already said in the review that perpendicular lines have opposite reciprocal slopes. Reciprocal, I think I spelled that wrong, slopes. Okay, so for example, if we had y equals the 2x minus 4, like we did over here, an equation would be, well, the opposite reciprocal of a positive 2 over 1 is negative 1 over 2x. And then it doesn't really matter what the b's are. So this could be 10, it could be 100, it doesn't really matter. Since the slopes are opposite reciprocal, they are perpendicular automatically. Okay, notice also in all of these that these are all in y equals mx plus b. They're all in slope-intercept form. So must be in slope-intercept form if you guys want to use this shortcut, slope-intercept. Okay, and that might help you out with number 6. Okay, so for number 5, if you look at y equals 3x plus 7 and y equals negative 3x minus 4, just look at the slopes. They're not the same, so that means that they can't be parallel or coinciding. They're not lying on top of each other. They're not the same lines. They're not opposite reciprocal, so they can't be. So then they can't be perpendicular. So our only other option is that these lines are intersecting. That's it. That's all we can classify them as. All right, last question you're going to do is number 6. Let me scroll down so you can see what that one looks like. And then the fun fact of the video. Did you know the term nerd, it is awesome to be a nerd, P.S. The term nerd came from a Dr. Seuss book called If I Ran the Zoo. Yay! Yay, nerds!